All right, so moving forward, for this unit, we're gonna do polar equations. Just like when we did the parametric equations, remember how I took a day and just taught you what parametric was? And I was like, this isn't necessarily gonna be on the AP exam, but in order to do derivatives and integrals with parametric equations, you have to know what they are. Today's kind of like that. You're not gonna see problems necessarily like this on the AP exam. You're gonna do derivatives and integrals with them, but you have to understand what polar is before you can get to that stuff. So that's why we're gonna take a day and do this. That's why you may have noticed your homework is just an AP practice problem. It's not like a for a grade assignment because like there aren't any problems that necessarily go along with this. So polar form, rectangular form is x comma y, like the xy plane that you guys are all used to. Polar form is r comma theta. Oh wait, have you heard of this? Oh, you're gonna be okay. You're gonna be okay. All right, so like here's your I guess coordinate plane. R is the radius, which would just be how far away from the origin you are. Theta is the angle of rotation. So like if your point ends up right here, just like for example, okay, here, you know what, I'll color code. This would be the radius, like that distance is R. And then the amount that you've rotated, that's theta. So like this angle is theta, like how far you've gone. So it's like the unit circle, except the radius would have to be 1 for you to be on the unit circle. But for us, R can be anything. So like, yeah, I want you to kind of think of it that way, but you're not necessarily on the unit circle, okay? The pole is the origin. So if you hear them mention the pole, that's a vocabulary word that just means the origin. And it's 0 comma any angle. Theta can be any angle. It doesn't matter how much you've rotated. If R is 0, you're on the origin. Does that make sense? Like it doesn't matter what your amount of rotation was. If R is nothing, you're at 0. Okay. So to relate this kind of to the unit circle, but R won't necessarily be 1, you have this amount R. If you drop down that right triangle, this would be X and this would be Y, because we want to be able to convert between polar and rectangular coordinates. And so that's what we're going to use. Sine, cosine, tangent. Welcome back to geometry class. All right. Here's our angle theta. Sine of theta. Oh, and this is so funny because I'm doing this in pre-calc. You're so Katoa. Sine would be what over what? No, I'm glad that you're talking to me. So it would be y over r. So whenever you're doing the unit circle, that's why sine just ends up being the y value, because r is 1. So it would just be y, right? Sine, oh, I just did sine of theta. Cosine of theta would be what over what? I'm glad we're reviewing this. Good, so that would be x over r. And then tangent of theta, good, so that's y over x. Okay, we're gonna come back to that, just make sure you have that written off to the side there. Okay, so let's plot the following coordinates. And what you'll see on a polar grid is they'll put like these circles. It almost looks like a raindrop that fell into a pond. Like the smallest one, that's a radius of 1, and then a radius of 2, and then a circle with a radius of 3. So you can count out for r, like how far away you are. So if you're going to do 2 comma pi over 3, you're going to rotate pi over 3 amount. Now I'm not going to get out a protractor and try to measure these. As long as we get the quadrant right, it's going to be okay. What quadrant is pi over 3 in? The first. Okay, so go out pi over 3, and then you want the radius to be 2. So go to the second circle. It'd be like right about there. That's where that point would be. All right, so let's try this one. Negative pi over 6. What quadrant is that going to be in? Fourth, because you've rotated backwards. So you would go backwards pi over 6, and then the radius is 3. So just go to like that third ring out. Oh, sorry, I'm on this one. So like right about there. Those are just radii. I'm not drawing them very well because I'm not a great artist. But the smallest one, that's like a radius of 1. This is a radius of 2. It's a radius of 3. So see how I put it's so that you can count outwards, like to go that far. I know it looks like what do you do in chemistry with like the electrons? You know what I'm talking about? It looks kind of like that. It's not that. But... So what quadrant would 11 pi over 6 end up with? Yeah, do you see where I'm headed with this? Because it's going to be this exact same point, right? So you can have a point that's in the exact same spot, but with different coordinates. So the next thing that we want to be able to do is convert from rectangular to polar and back again. I make sure I do this the right direction. So to go from rectangular to polar, you would have an x and a y and need to get an r and a theta. So to get r, you're going to do Pythagorean theorem. It would be x squared plus y squared equals r squared. So you would have an x and a y, you would plug them in. Basically, you're just doing Pythagorean theorem. And then to get your angle, you're going to use this right here because it involves the x and the y. Do you see what I'm pointing to? Tangent of theta equals y over x. You would need to get theta by itself, you would need to tangent inverse that, like untangent. So theta would equal tangent inverse of y over x, or arc tangent if you want to write it that way. But to convert from rectangular to polar, you would have the x and the y, you would need to get the r and the theta. To go back the other way, you're going to have the r and the theta, you would need to get the x and the y. So now we're going to look at these two. So let's do the x first. I'm looking at the cosine right here. Do you see how if I multiplied this r to the other side, I would have x by itself? So x is going to equal r times cosine of theta. And then for the y value, I'm going to use this one right here. If I multiplied the r to the other side, y would equal r sine theta. Okay, so let's convert them. And I like to draw a little picture of it too, because I like the visual. All right, so we're going to convert to rectangular form. So we're going to, actually, I should have written these the other way around. So we're going to use this right here. So x is going to equal r cosine of theta. R is 2, theta is pi. So it would be 2 cosine of pi. So what is cosine of pi? That's -1 times 2 would be -2. And then y is going to be r sine of theta. So 2 sine of pi. So what is sine of pi? 0. So we got our x is -2, our y is 0. So here's our coordinate point. And if you think about where that is, it would be right here. So if you rotate pi amount and then go out 2, that's where that would end up. Those are the same thing. All right, so let's try this one. X would equal r cosine theta. So r is square root of 3, and then cosine pi over 6. So cosine of pi over 6 is square root of 3 over 2. And so square root of 3 times square root of 3 would just be 3. So you get 3 over 2. And then y is going to be r sine theta. So square root of 3 sine pi over 6. So sine of pi over 6 is 1/2. So it would be square root of 3 times 1/2. So square root of 3 over 2. So this would be your coordinate point. And so just to do a visual of that, I like a picture. About what would be square root of 3 over 2. but like a little bit shy of 1. So you'd have like, I don't know, right about there. I wish I had drawn that a little bit bigger now. But the point I'm trying to make is if you go in the X direction, like if I make a right triangle out of this, if you go in the X direction 3/2 and in the Y direction square root of 3/2, this radius will be square root of 3. Like if you use those numbers and do the Pythagorean theorem, it's going to work out. I promise. You can do it if you don't believe me. But if you do 3/2 squared plus square root of 3/2 squared, you will get square root of 3 squared, or 3. Okay, so that's where that point would be. I'm sorry, my picture ended up kind of small. All right, we'll do these two and then I'll give you a break. All right, convert to polar form. So now we're going to use this right here. We have the X and the Y. We need to get the R and the theta. So first do the Pythagorean theorem. We're going to use this right here. So we'll have -1 squared plus 1 squared equals R squared. These would both just be 1, right? So 2 equals R squared. And so R is square root of 2. All right, and then we have to get the angle. So theta is going to be tangent inverse of y over x. So -1, or sorry, 1 over -1, I guess it doesn't really make a difference there, but either way, it would be -1. It should be y over x. So 1 over -1. So tangent inverse of -1 would be pi over, or actually it'll be something pi. You need a place where they're the same, but opposite signs. Oh, there we go, 3 pi over 4. That would be right here. If you go 3 pi over 4, you would have -√2/2, +√2/2. Anything over itself is 1, it's just this was negative, so 3 pi over 4. So your coordinate point is r comma theta. So it would be square root of 2 comma 3 pi over 4. It should be, but it would give you 3 times pi over 4. Oh, no, you know what? So okay, hold on, let me finish this last one and then we'll have a talk about that. That's has to do with how the calculator is programmed to give answers. Hold on, let me finish. Well, okay, you know what? We'll just go ahead and have that conversation now. When you do tangent inverse, the way the calculator is programmed to do the inverse functions for tangent, it will only stay in quadrant 1 and 4. So you can either rotate upwards this way or downwards that way. So it would give you the one that's down here. But look at the problem. How do I know it's not in the 4th quadrant? 2nd quadrant. The point was -1, 1. So I know it has to be up here. Do you get what I'm saying? Like the calculator is going to give you the answer that's down here because it's programmed to stay in these 2 quadrants. It won't come over here. Well, it has to do with the domain of the inverse function. But I know that this one has to be in quadrant 2 because the point is -1, 1. And again, this is why I always kind of like to draw a picture. Like that's why I tend to draw it because then I can see it and I understand what's going on better. Here's your point -1, 1. And so this amount that you rotated is 3 pi over 4. And so here's -1, here's +1. If you make a right triangle out of that, this hypotenuse would be square root of 2. And if you do the Pythagorean theorem, you'll see that it works out. That radius would be square root of 2. But I know it had to be the 3 pi over 4 because it was in the 2nd quadrant. Does this make sense? Or like, I tend to keep rambling if no one like shuts me off. Like, we got it, Miss Cole. I just keep on talking. I'm like, all right. All right, so we have the point 0, 2. We need r and theta. So you're going to do the Pythagorean theorem just like we did here to get r. So it would be 0 squared plus 2 squared equals r squared. So this is nothing. This would just be 2 squared equals r squared. And so r is going to be 2. And then we're going to do the same thing that we did here to get tangent, only as a heads up, this one's not really going to like work out too nicely. You would have tangent inverse of y over x, that would be 2 over 0. That's undefined, and that means that there is an asymptote there. So we need to find a place where tangent has an asymptote, and that would be at pi over 2. At pi over 2 on your unit circle, what are your coordinates at pi over 2? 0, 1. If you do tangent y over x, that's where you end up with an asymptote. And how did I know it had to be up there, like versus somewhere else? Because there's a lot of asymptotes in tangent, but how did I know it had to be there? Because it's the point 0, 2. Again, that's why I like a picture. Like this point would be right here. And so it means you rotated pi over 2 amount and then went out a distance of 2. So the coordinate is r theta. It would be 2 comma pi over 2. So I worked that one out, but in all honesty, when you have like 0, 2, or like 2, like when you have the quadrant ones, like pi over 2, pi, 3 pi over 2, I would almost just do those by like drawing a picture and kind of looking at it. If that makes sense, like I would just go, oh, this is 0, 2. That means I rotated pi over 2 and the radius is 2. Like I would probably do this problem without doing all that work. Like I showed it to you guys, but I probably wouldn't do all that. All right, so for each of these, we're going to convert this to rectangular and then draw a quick graph of it. So for the r, we're going to do the Pythagorean theorem. It's x squared plus y squared equals r squared, and 2 squared would just give you 4. So that is the equation in rectangular. I know we didn't solve for y, but it's fine. There's an x and a y and an equal sign, so it's the equation in rectangular. And that's an equation of a circle. I know geometry feels like it was a million years ago, but do you remember those x squared plus y squared equals r squared? It's an equation of a circle, which should make sense because if r is 2 all the time, it's just going to be a circle with a radius of 2. That's all that this graph is going to be. Do you remember doing those? You would find the center of the circle and then like go 2 in each direction and try to draw it, and it never turns out real great. It's kind of like, yeah, like a diamond instead of a circle. But good enough. Or a pistachio. All right, for this one, we're given theta. So tangent of theta, so tangent of pi over 3 equals y over x. It's opposite over adjacent. So now we have to do tangent of pi over 3. I'm just going to go ahead and draw that from the unit circle so that you guys can see it. Here's pi over 3. This side would be square root of 3 over 2. This side would be 1/2. If you do this over this, what's going to happen to the 2's? They cancel. It would just be square root of 3 over 1, which is square root of 3. Now that's the equation in rectangular, but I am going to solve for the y this time because it's actually worth it for this. If you multiply over the x, you would have y equals square root of 3 times x. And although it looks kind of strange with the square root in it, that's y equals mx plus b. Except b is nothing, so it's going to go through what? It'll go through the origin, and it'll have a slope of square root of 3. So up square root of 3 over 1. It's going to be linear. It'll be something like this. I didn't put tick marks on the axis because it's square root of 3 is the slope. So good enough. All right, and then for this one, we have x equals r times cosine theta. I picked that because secant and cosine are reciprocals. You'll see what happens in a second. X equals r, which is this, times cosine of theta. So those cancel and you just end up with 1. It's x equals 1. So what kind of line is that? Yeah, it's just a vertical line at 1. So that's kind of cool. Yeah, so to answer Evan's question before, you can't change any equation into rectangular, but certain ones. So like a circle or a line, like something like that, you can change them. And then here we're going to do a couple that are a little bit more complicated, all right? And I'm going to take my time. I know there's only these last 2 problems. This is going to take us a little while because I'm going to show you a few ways to do this and talk about them a little bit so you can understand what's going on. All right, so we are going to make ourselves a table for theta and r. And you want to plug in values going around your unit circle. So I'm going to start with 0 pi. Now this one, because there's that 3 in there, I'm going to kind of make every stop along the way. You're going to be all right. Okay. So we're going to do pi over 6, pi over 4, pi over 3, pi over 2. And then into the second quadrant, it will be 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. Again, you're going to be all right. That's not actually that many values. Do you remember when we did Euler's method and you had to like do all that messing around with the tables and stuff? You all survived. You're fine. Oh, wow. You're in for a bumpy ride in this unit. No, I mean, everything. Yes, and that's where I'm headed because it's going to go around. Anyway, let's go ahead and plug those in. Plugging in 0 pi. 0 times 3 would just be 0. Cosine is 0. 1, good. Times 2 is 2. No, you had it. You got it. This is like the Monday B day. All right, pi over 6. If you plug in pi over 6, when you multiply it by 3, it immediately becomes pi over 2. Cosine of pi over 2 is 0. Good. All right, plugging in pi over 4. You would multiply it by 3. So we're in the second quadrant. Cosine of 3 pi over 4, that is negative, so in the second quadrant, square root of 2 over 2. Multiply that by 2, the 2's will cancel, so it is just negative square root of 2. So when you plug in the pi over 4, you multiply it by 3, so it's 3 pi over 4. All right, pi over 3, when you plug that in, the 3's cancel, it would just be pi cosine of pi. Negative 1, good, times 2, negative 2. Plugging in pi over 2, multiply it by 3. That'd be 3 pi over 2, that's at the bottom. Cosine of 3 pi over 2 is 0. Plugging in 2 pi over 3. Again, you're all going to be okay. The 3's cancel. Cosine of 2 pi would be 1 times 2 is 2. Plug in 3 pi over 4. Multiplying that by 3, that would be 9/4. Come with me on this. 8/4 would be the whole way around, right? So 9/4 means you went a little bit further and you're back in quadrant 1 again. So it would be square root of 2 over 2 times 2 would just be square root of 2. All right, 5 pi over 6. When you multiply that by 3, that becomes 5 pi over 2. You went the whole way around and you're back up at the top again. Cosine of that would give you 0. The x value for that would be 0. And then plugging in pi. All right, last one. If you multiply it by 3, 3 pi is actually in the exact same place as 1 pi. So it'd be negative 1 times 2 is negative 2. All right, let's draw a picture. I hope that I'm able, like my artwork is able to make this look good because these turn out kind of pretty if I can draw it right. Yeah, they are awesome. I'm going to show you how to do that. Just hold on. All right, so 0 pi is right here. You haven't rotated anywhere. You're going to go out a radius of 2. So we're going to start right there. And kind of like the parametric, do you remember how we put an orientation on it? You kind of want to pay attention to that, like what direction you're headed as these like go around. Okay, so that's our starting place. Pi over 6, that would be kind of like right here, but we went 0, so that's the origin or the pole. So if you want to start connecting it, it's going to go like that. Again, I really hope my artwork holds up and that this looks cool. All right, pi over 4, that would be right here. But we went negative pi over 2, so that's going to put us like over here. Pi over 3 would be like right here, but we went negative 2, so it's going to be down here somewhere. And then the next one, we're back to the origin again, or the pole at 0. So it's going to like, trying to look at the one I already have drawn so I can make it look nice, but something like that. because you're going to go through the origin several times, but they're all different amounts of rotation. All right, 2 pi over 3, that's going to put you over here. Radius of 2 would be, I don't know, about like that. 3 pi over 4 would put you right here in the middle of the second quadrant. That'll be like right about there. And then we're back to 0. So that's going to be this petal. And then pi negative 2. Well, pi would be over here. But we went negative 2, so it's this direction. And so it's going to put you right back where you started. Okay, that turned out pretty good. But it's going like this. Well, it's supposed to look like a rose. They're called the rose curves. So if you look right here, you have n petals. They follow the pattern A cosine n theta or A sine n theta. You have n petals when n is odd. So like n was 3, we had 3 petals. But if n is even, like in this one, n is 4, you get 8 petals. So if n is odd, that's the number of petals you get. Like here, n is 5, there's 5 petals. Here, n is 2, you get 4 petals. So if it's even, you get double the number. Okay, and so it's important to be able to set these equal to 0 and be able to solve them. I'm going to put something else right here. Again, I told you this was going to take a while. I want to have a more in-depth conversation about this. But say you wanted to set this equal to 0. Just humor me because you're going to need to be able to do this. On the other page where we have some space, 2 cosine 3 theta, we're just going to set it equal to 0. Because you do need to be able to solve these. So you would divide over the 2. 0 divided by anything is just going to give you 0. And so you're looking for places where cosine is 0, and you would set 3 theta equal to that. Think about your unit circle as you rotate around. Where is cosine, which is the x value, going to be 0? All right, pi over 2 is the first one. When you divide over the 3, you're going to get pi over 6. So you hit the pole at pi over 6. Where's the next one? 3 pi over 2. Divide over the 3, the 3's are going to cancel. You hit the pole again at pi over 2. So you keep hitting the same point over and over again. We'll just do one more. Where's the next one? We had pi over 2, 3 pi over 2. The next one's 5 pi over 2. The next one would be 7 pi over 2, and then 9 pi over 2, and then 11 pi over 2. Anyway, I'll only do one more. And then this would give you 5 pi over 6. If you look at the table we made, these are all the values where we ended up at 0. Okay, I can tell I'm losing you. I was going to say something about changing it to rectangular, but we'll just do that for this one because I can tell you guys have like had about enough of me at this point. All right, so for this one, go ahead and make yourself a table. Now, I plugged in like every single last value here. That was because there was that 3 in there. Do you see how this one's just theta? We're going to be able to get away with just doing pi over 2 pi, 3 pi over 2. Like this one will be a little bit of a simpler problem, even though it kind of looks more complicated there. But I do want to show you how you can change it into rectangular and still get the same thing. Like that's important too. So let's plug in 0. Cosine of 0. 1 times 5 is 5. 2 minus 5, negative 3. Cosine of pi over 2 is 0. 2 minus 0 gives you 2. All right, pi. Cosine of pi would be negative 1. Negatives cancel, so that would be 2 plus 5, so 7. 3 pi over 2. Cosine of 3 pi over 2 would be 0. 2 minus 0 gives you 2. And then cosine of 2 pi, that puts you right back where you started. It would be 1, and then 2 minus 5 gives you negative 3. All right, so let's go ahead and graph it. So starting with 0 pi negative 3. Now 0 pi would be right here. And I keep saying right here, you kind of have to watch me point to this because I'll have a better explanation. 0 pi would be right here, but we went negative 3. So that's going to be this point. All right, and then pi over 2, that would be up here. Radius is 2. And this is going to look something like this. You are going to go through the origin. Hey, Ms. Cole, how did you know that? Let me finish graphing this, and then I'll show you on the other side. We'll set it equal to 0, and you'll see how I knew that. All right, also because I've done a lot of these, right? Going to go through the origin, come up to here. All right, pi 7. Pi would be over here. Just go out 7. Looks kind of like a snail. These are cool. Or like a heart, sort of. All right, 3 pi over 2 would be down here. Go out 2. And then 2 pi would be over here where 0 pi is, but you went negative 3. So it's going to put you back where you started. So you're going to go through the origin again and then end up back where you started. So it kind of looks like a heart. That's cool. So cool. You know it is. It's really neat. All right, now these are called, now I say limacon, but you can YouTube how to pronounce this and get like a dozen different pronunciations, like limacon, and I say limacon, I don't know, whatever you want to call it. But anyway, they can look like this. This one is just dimpled. So anyway, those are cool. But if you set this equal to 0, what was it? 2 minus 5 cosine theta equals 0. Because it is going to hit the origin. What would you do to start solving that? Subtract 2. Yeah, this is basically a review of how to solve equations here. Negatives cancel. You would divide by 5. Get 2/5. Now I don't know exactly what that is because it's not on the unit circle, so I don't know like off the top of my head. But there would be 2 places where cosine of theta would equal 2/5. You would have one of the angles right there, like that amount of rotation. And then the other one down here, it would be this amount of rotation. So whenever we drew that, you know how we started here and we went through the origin the first time? And then we kept going and then we hit the origin the second time? Those were the 2 times that that happened. So that's why it went through the origin. All right, let me show you how to do them on the calculator. Because they're cool. And don't you kind of mess around with the calculator, don't you, and play with these? You've done this before. All right, so we'll do number 7 first. Go to mode and go down, see where it says function. It should say rectangular. It really bothers me that it says function instead of rectangular, but whatever. Anyway, we did PAR, we've done parametric. Go over to POL, that's polar. Go ahead and put it in polar mode. And then go to y equals, oh, I was messing around with something else there. Now, when you hit the variable key, it'll come up as a theta. So let's go ahead and type in number 7. You're going to do 2 cosine 3 theta. And then we'll go to window. And in our table, we did 0 to pi. So make it go from 0 to pi. The step, remember when we did parametric and I said leave it as 0.1, like around 0.1 is fine. I don't know where this decimal came from in mine, but good enough. Maybe the last thing I did. Yeah, I don't know what I did. I usually just kind of leave that alone. And then look at your grid. If we do like -3 to 3, we should be able to see everything. So make your X's and your Y's -3 to 3. That's just so you can see the whole picture. And when you hit graph, watch how it goes. Do you see how it, like there is an orientation to it. Like it does it really fast, but I'm proud of my picture. It actually looks pretty good. Surprised that it turned out that way. All right, let's go and try this one. So go back to y equals, even though it's not y equals, it's r equals now. And go ahead and do 2 minus 5 cosine theta. Now for this one, you're going to need to make it go 0 to 2 pi. to get the whole thing. If you only do 0 to pi, you won't get the whole thing. Which actually here, you guys do 2 pi, I'll do 1 pi so you can see what it looks like. And now you're gonna need to bring your x minimum down beyond -7 so that you can see the whole thing. I would just make that -10 and leave the rest of it the same. But that's what you get if, like, I only went to pi. Did you guys go to 2 pi and it drew the whole thing for you? That's neat. They're cool. I just want to show you real quick, and I'll just do this one because this one's a little bit easier of a problem, is how you can turn it into rectangular coordinates. All right. X equals r cosine theta. So this thing is r, and then times cosine theta. So that whole thing is r. And then y is r sine theta. The other reason I'm harping on about this is you're going to use this a lot next class. So x is r cosine theta, y is r sine theta. So I'm going to make a table, and this is going to be just like we did with the parametric ones, except instead of t x y, it's theta x y, and I'm going to plug in these same values. So I'm going to plug them all into x first. So cosine of 0 would be 1. So you'd end up with 2 minus 5, which would be -3, times 1 would be -3. Cosine of pi over 2 is 0. So that's going to make the whole thing go to 0. Cosine of pi is -1. This ended up being 2 plus 5, which is 7, times -1 would be -7. Cosine of 3 pi over 2 is 0. That makes the whole thing go to 0. 2 pi puts you back where you started. Now I'm going to plug those into y. So right here. Cosine of 0 was 1. Oh, but you know what? Sine of 0 is 0. That makes the whole thing go to 0. Cosine of pi over 2 would be 0. This would be 2 minus nothing, which is 2, times 1 would be 2. Sine of pi would be 0. There's a lot of zeros in this one because it's the quadrant angles. Cosine of 3 pi over 2 would be 0. So 2 minus nothing is 2. Oh, but sine of 3 pi over 2 is -1. So I'm sorry, times a -1. So -2. And then this one puts you back where you started. So look, I know you're tired, but please pay attention to this because I want you to understand it. If you plot these coordinate points, it comes out to the same thing. Do you see how this is the point -3, 0? And then you come around here and that's 0, 2. And then that's -7, 0. And then 0, -2. And then back to -3, 0. So we changed it to rectangular. And then, oh, question? Yes. Yes, so like, now you can't see it on the calculator because it won't trace over itself, but it would keep going like this forever. Like you keep rotating around and around. Now I didn't put one on here like this, but you can also just have a regular circle. We graphed one where R was 2. And then these ones are cool. They're called lemniscates. And it looks like a little infinity symbol, which is just cool as well.